I want to talk about snatching victory from the jaws of defeat. Now, some of us encounter failures that we find insurmountable. Others find failures as opportunities. And I fall in the latter category. Yesterday, I decided to make the first chips on my Fadal, and it was a challenge. I had one failure after another, that all kept coming. Now, those failures by themselves, stacked up, could result in me not producing anything, or producing something but it not meeting the requirements that I set forth whenever I wanted to make them. But ultimately, I achieved my goal, and through incremental improvements and little changes at each step of the way, I was able to get what I wanted. Now, I'd like to share that with you. Now, the first thing that I encountered was this artsy shot that I have set up here with the shallow depth of field. I borrowed a camera, and unbeknownst to me, all digital SLR cameras have a maximum recording limit of 30 minutes because of a import tariff on camcorders. Now, the camera I was using, and I'm using now, had a limit of 9 minutes and 50 seconds. Now, if you're trying to shoot a machining video and you're trying to get one long shot of a program running, 9 minutes and 50 seconds isn't going to do it whenever the program takes a half hour. So I have a few gaps in my footage as a result of that, but I was able to compensate, and I can stitch something together and recover that. You know, originally my idea was I wanted to make something artsy like a This Old Tony production. You know, the story of, you know, three little T-Nuts, you know, Papa T-Nut, Mama T-Nut, and Baby T-Nut. And how the little T-Nut, the baby T-Nut, was too small to fit my machine, and the Papa T-Nut was too big. And Mama T-Nut, well, she was just right. But I only had a handful of Mama T-Nuts, and so I wanted to make more. Well, it didn't turn out all artsy like that. But I do appreciate This Old Tony's content. So beside the camera, some of the challenges I ran into, I went to go and set my tool settings or tool offsets, and found that the air solenoid that operates my spindle orient decided to stop working and didn't want to cooperate. So I had to take that apart and rebuild it and put some new seals in it, and I got that working. Then I set my tool offsets. Everything went fine with that. I had a pretty good plan. And I went to set my fixture offsets. That didn't quite go to plan. The fixture offsets on a Fadal, E0 is the table, that's your tool settings, and then E1 is an offset from E0. So basically, however far above the table your part is, you put that in your Z offset. So it takes a negative number from your Z0 and then adds a positive number to that to get your fixture offset. It took a few tries to figure out what I was doing wrong, but I eventually did figure it out. So once I got my part fixtured and I got my tool offsets right, and I ran a drill bit into the part at faster than programmed feed rate because I didn't have my fixture offset right, then went on to running programs. Now, this particular control, being 32 years old, it doesn't really have a dry run mode like newer controls would have, where you can run the part an inch above. You'd have to change your fixture offset to run it an inch above. But that 32-year-old control part, keep that in mind. I downloaded the NC Fadal, or Fadal Assist as it's called, and put it on my Windows 8.1 laptop. I ran the compatibility troubleshooter, and there's notes on the internet that says, oh yeah, you can run it under this as long as you set it to Windows 95 mode. Set it to Windows 95 mode and the program crashes when it tries to open a file. So run compatibility troubleshooter, it says Windows XP Service Pack 3, which I was dubious about. I let it run, okay. Couldn't find a USB serial port. Okay, I'm not going to fight this. I already know that that's going to be a losing battle running a 15-year-old or a 16-year-old program on a new laptop. So I went and I got my 16-year-old laptop. I bought a IBM A30P in 2001, and it's got a real serial port on it. So I plugged that in, I installed the NC Fidel software on it on Windows 2000, and it worked flawlessly. I was able to contact the control and download the program, and everything went fine. So I got past that hurdle. Then I'm actually running the program, and like I said, I crashed a tool or crashed a drill bit. Didn't break anything, just stalled the spindle, and the Z-axis alarmed out and all that good stuff. So just reset everything, started over. Did my drill op, everything went good. Did a facing operation, everything goes good. And then it goes through, it does the waterline machining of all the the Z depths for the T-nuts. And then I get to the last operation, which is chamfering. It starts out in the middle of the part and starts to chamfer, and the chamfer tool looked like it was about 30 thousandths too low. So I stopped the program. I went and comped it in the control. It took me a couple tries. I got it to a height that looked right, and then I let it run. It didn't cut any of the T-nuts on the end of the bar, just in the center of the bar. And that's when I knew I had a banana on my hands. If you've ever tried to machine a banana, it's never very fun. So ultimately what I ended up doing was taking the comp out of the tool and set it back to where it was 30 thou too low in the middle, but not after I beat the living hell out of that bar with a hammer and reset it in the vise and just beat it with a hammer. When I finished the part and I took it out of the vise, I got an interesting surprise. I knew that it had bananaed a little bit, or potato chipped as you call it, but to the extent that it did, I was shocked. And I'll insert that picture here. Now, if you've ever worked with cold rolled, you'll know what I'm talking about. Cold rolled material is just that. It's cold formed. They take material, they run it through a roll, and it creates a dimensionally uniform piece of material with nice sharp corners. The problem is when it does that, it creates a lot of stress in the skin. And when you machine that skin away, you then release the stress in the part, and the forces are unbalanced. When the part has, or the material has been, as rolled, all of the forces, all the stresses in the part are equalized. But when you take a skim cut, say a 50 thousandths facing cut off of one side, the part will bow towards that cut. Well, I took the 50 thou facing cut, and then it did the waterline machining, which is Z depth. It goes and it cuts everything at the same Z depth, and then moves down and then cuts everything until it gets down to the finished depth. That part had a lot of bow in it, a lot of bow. Now, I could have fixed this if I had anticipated it. I didn't anticipate that I was going to have that much trouble because I had two 6-inch vices with 6 inches in between them, and I didn't think that that was going to be a problem because, two vices clamping, it wasn't that unsupported. But had I done something else, had I been smarter in the beginning, I would have avoided that. And that is, skim one side, put that down on the parallels, and then run the part. So that way you start out with an imbalanced amount of stresses. Your facing cut takes that exact same amount off the other side, and then the stresses are equalized. And then you go and you machine the part. Well, at the end of the day, I was able to get finished parts out of it that were exactly what I wanted, T-nuts, that would fit my machine. And it was the correction of all these little errors along the way, all these little problems that I ran into, and challenges that needed to be solved. It was those that ultimately gave the parts character. And I learned a lot in the process, or relearned things in the process. So I think it came out the way I wanted, and if you guys appreciate this content, just subscribe and give me a thumbs up. So, thanks for watching. Bye.